They never did like Mama's homemade dress. Papa's bank book wasn't big enough. Okay, so final lab of the semester, or final online lab of the semester. You're going to be working with the gas laws. So the gas laws are relatively simple. There are a few sub-laws, and then we get to the universal law. So the individual laws, you have Boyle's law, which shows the relationship between pressure and volume. Okay. So if you increase the pressure on a system, the volume will go down. Okay, you squeeze it, right? So you can find how a system will change volume responding to a change in pressure. Then we have, say, pressure and moles. If you increase the amount of gas inside of a container at constant volume, then the pressure will increase. You get the same sort of relationship with volume and moles. If you hold pressure constant and you pump in more gas, then the volume will increase. And finally, you get a similar sort of relationship with temperature. Okay. If you increase the temperature of a container at constant pressure, then the volume of the container will increase. It'll expand. Or if you hold volume constant, this would be a very dangerous thing to do, but you could increase the temperature of a constant volume container, and the result would be an increase in pressure until the container exploded. So what you can do is you can relate all of these things together, such that, PV over NT is equal to a constant that we call R, where R is the universal gas constant, 0.08206 liter atmospheres per mole Kelvin. It's just the constant that relates all of these variables about a gas to one another. And the particular value of R does change, depending on what units you use. We normally state this universal gas law as PV equals nRT. If you know any three of these values, then the fourth is fixed. Okay? At a certain volume and temperature with a certain amount of gas inside that container, you will have a specified pressure. You wouldn't be able to change it to anything else. And if you change any one of those, then the others will have to shift in response. Now, what this means is that we have another path to moles. Because you'll know temperature, you'll probably know volume, you'll measure pressure, right? So you'll have another way to calculate moles, meaning we have another way to work with stoichiometry. So all roads lead to mole, and then you do stoichiometry to get to another substance. So I really recommend you watch all these videos to get a more full explanation. So they're going to give you this fun little simulator to play with. What it does, it's not all. I mean, you play around with this. You pump gas particles into this container, and you can see how that changes pressure. You can also see that the big particles are moving slower, the small particles are moving faster, even though they're at the same temperature, because temperature is a measure of kinetic energy, which is related to both mass and speed. If you have a lower mass, you're going to have higher speed. You can also change the pressure here, or change the temperature. As you heat it up, you see the particles move faster and faster, and the pressure increases. You can also, cool it back down. Oops. Can't change it there, have to change it here. All right. So as you cool it way, way down, the particles move slower and slower, and that decreases the pressure. You can also change the volume, which means that the particles are colliding with the walls left off, and you can do all sorts of stuff here. You can hold things constant so that some things can't change. You got lots and lots of options. Okay. So This simulator will let you sort of experiment and play around and see more directly what effect these different things have on pressure. Okay? So you increase the temperature, you increase the pressure. Decrease the volume, you dramatically increase the pressure. Because there's just less space, the particles are running into stuff more. That's all. It's a neat little simulator. All right. Then you're going to collect hydrogen gas over water. That's not really a problem. So what's happening here is you got a reaction between zinc and hydrochloric acid that produces hydrogen gas. The test tube is sealed, and then it's just got a little tube, a pipe, that goes into this beaker. The beaker is full of water, and it's sort of turned upside down, and it will collect the hydrogen gas inside that beaker, and thus you'll get a changing volume of gas inside that container. And thus you will be able to measure the volume of that gas, and they'll have a nice detailed explanation about how you do that. But the other complication is the fact that there's going to be water vapor in there along with your hydrogen gas. So, boom, we go over here, and you have to pay attention to the temperature. So you'll also be measuring the temperature of everything. And at different temperatures, you get different amounts of water vapor. Water evaporates. It evaporates faster in warmer conditions, slower in cooler conditions. This is because particles of the water molecules, are constantly leaving the water. And this creates water vapor, which exerts pressure just like any other gas would. And the amount of pressure it exerts is going to depend on the temperature. So here at 15 degrees Celsius, the vapor pressure is 12.833 torr. Now remember, torr in measures of pressure, 1 atmosphere equals 760 torr. So at 15 degrees Celsius, you have 12.833 torr, and that is a very small amount of pressure. Nevertheless, it is something you're going to have to take into account, because you're going to be collecting the hydrogen gas over the water, you're going to be measuring the volume, you're going to be measuring pressure, all that stuff. And you're going to have to subtract, basically, the water, so that you get the actual amount of hydrogen that you produce accurately. Otherwise, you would overestimate how much hydrogen gas there is in there. So you're going to measure the volume of your hydrogen gas, and then you're going to do stoichiometry. There's really that's not excessively difficult. It's regular stoichiometry, but with gases, and this Pevnert stuff. This gas law here. This just gives you another method for measuring moles. You can measure mass of a solid to get to moles. You can measure the volume of a liquid at known concentration to get moles. And now you measure pressure, volume, and temperature of a gas, and you know how many moles you have. That's all. It's just, all roads lead to mole, and moles is what lets you do stoichiometry. I don't anticipate this will be an excessively difficult lab. There's going to be some math, obviously, but the math isn't all that hard. Okay? It's, just multiplication and division. Just try to keep track of your initial and final stuff if they ask you to do any problems like this. Okay. And don't 0.08206. Don't forget your R value. Okay. And with that, I think that's everything you really need to know for this lab. So I will see you later.